This is going to be a video about blueprint interfaces, not to be confused with user interfaces. It's a method of communicating between objects without needing to know their class types, meaning you don't have to cast. It's primarily used to allow kinds of interactions between multiple actor classes, and it's also used to prevent circular references within your coding, which can lead to memory leaks or crashing, or even worse, corrupted blueprints. We're going to do a couple things. We're going to take our structure that we made previously, and we're going to impose some limits on it. Mainly, we're only going to allow a few to be placed in the world at any given time. This isn't tribe-based or personal, it's just a global, there's only 3 allowed on the server kind of thing. We're going to do it the simple way, but it's got a few issues. And then we're going to do it the more complicated way, but it works better and looks nicer, and it's a better experience for users. So the first thing we do is we go to our structure and we go to the allowed to build function. You want BP is allowed to build EX. You'll also need to enable this in class defaults. And what this is it fires on the client when they're trying to place it, and then on the server when it's about to be placed, if they're allowed to place it in the first place. If this number returns anything that's positive, that means it was a valid allowed to place. Anything negative will be denied. And when it's denied, you can input your own reason for why it was denied. Look for a reason in the function overrides. And you want BP override can't build reason. It has the reason index and the string result. So we'll just do something like a switch on the integer. And we'll put in something like -42. And if it's -42, we'll say something like too many already built. Otherwise, we'll just continue. In the allowed to build, what we're going to do is we need to find all of our structure that's already been placed. There's a bunch of different ways of doing this. One of them is get actors of class, like this, and you can put in your class type. That's fine. There's another one, which in this context isn't super useful, but you can use it for whatever you wish. And it involves reading tags on structures. In the class defaults, if you look for tags, this array right here, you can add any word you want in there. So just like dummy smithy. And what happens is it auto registers in a list on the server anytime you place the structure, which can be useful. So in order to read that list, we want k2 get world, and then we want get world settings native. Then there is a actor with tag. Get actor with tag, or get actors with tag v2 as pointers, which is a ridiculously long name. And the only difference is this one returns one actor, and this returns an array of actors. So since we want to know how many are placed, we want this one, and we'll put in the name of our tag. And this will be every instance of the structure. Well, we just need the length, so we know how many there are. And if it's, say, greater than 3, remember, we always want to return a reason. So we can just do this. So if we have more than 3, we can set our reason to negative 42. Again, this number doesn't matter. Just make sure it's a negative so it's denied. So if it finds more than 3 structures, we'll say that it's an invalid placement and it should deny placement. The problem with this is that the client is only aware of structures that are within relevancy range, which is like 36,000 units, which is substantial space, but not the whole map. So the client won't be able to find all of these, so it doesn't work correctly. What we can do is just check on the server, because the server will have access to all of this. And this will fire correctly, with the slight problem of the client's preview structure probably won't be accurate sometimes. So if a bunch of them are placed off of screen, like across the map, and you try to place one far away, it won't find any locally, but the server will know that a bunch of them exists. It won't allow you to place the structure in the end. So we'll test it out real quick. So the third one places, but the fourth one's denied. So the problem was the preview structure was green, even though the server won't allow you to place it. Also, there's no message at the top saying why you couldn't place it. So if you're fine with this result, you can leave this as is, and you can just use client server notifications to display the reason to the user why they can't place it. If you give it a unique message ID, it will override the last one with that ID so it doesn't spam the whole screen. So it works much better. The preview structure is still a little unfortunate, but it does work. It is worth noting that blueprint interfaces can't really be accurately illustrated until you have a fairly large project. Something pretty simple like just what we're going to do here involving a storage box and then a singleton doesn't properly demonstrate the usefulness of blueprint interfaces. With larger projects, on the other hand, you could have a singleton that buffs the player. The player could get access to functionality on the buff via a structure, and now you have a singleton and a buff and a structure, and the structure needs the buff, and the buff needs the singleton to save data back. And then you throw in widgets, which are created by a buff, and then widgets go back to the buff and back to the singleton, and it becomes a tangled mess. After that point, somewhere, blueprint interfaces or other means of abstracting data pathways like dispatchers that we did previously become obviously better and simpler for untangling the mess of required references between blueprints. Nevertheless, we will illustrate it in a simple fashion here. We need the client to be aware of the total number of structures available at all times. We can't use built-in systems to do this because the structures will be, in all likelihood, way across the map and out of relevancy range, so the clients won't know that they exist. But we can manually track them ourselves and keep a running total of how many exist on the map at any given time. We are going to use our singleton for this. If you don't have one or don't know what that is, please watch previous videos. They're used several times. A few things need to be done first. Singletons are non-replicated actors by default, meaning they don't exist on the client, but you can turn it on by enabling replicates in the class defaults. And always relevant. We'll need a counter. So that we know how many exist. And it needs to be an int. And it needs to be replicated. What we're going to do is we are going to register our structure every single time one is placed, and then we're going to unregister it when it's destroyed, so we can keep a running total of the amount that are on the server at any given time. So on our singleton, we'll create an array of structures. It can just be primal structure. Object reference. And then we're going to create a register event. Just be a custom event. We'll just call it register. And we will pass in a structure reference. And then we want an unregister event. And all we'll do is we will add the structure in the register event and remove it on the unregister event. And then we will update the integer, the running count of how many exist. Now, because the singleton is replicated and our variable is replicated, the client will be able to access how many of these exist at any given time. So what we'll need to do on our structure, on begin play, which we already have, on the server, we'll need to get access to our singleton. Again, you can do this in a bunch of different ways. We can use getActorOfClass. The problem with this is that it'll now create a hard reference between our structure and our singleton. So instead, we could use the tags method if we wanted. Just for fun, in this case, I will. And we'll just call this CCA dummy. Now, there's no guarantee that our singleton has been loaded by the time our structure has been loaded. But just for safety's sake, you should run this code in a loop until you get a valid reference to your CCA, singleton, whatever. I'll just add it to a function because I like functions and I don't like to stick things in the event graph. So if our reference to our singleton is valid, we'll continue. And if not, we'll just set a timer for our getCCA function. It can be pretty quick, so that's fine. And it will fire this again and keep going until it finds a valid reference to our CCA. If it is valid, we can just save a reference. And this is where we'll register our event. We'll just make an event here. Again, you can make it a function or turn it into a function later, whatever. So because our reference is an actor, we can't actually call any of these events. If you look for register, it will not exist. This is not the one you think it is. This is for a mod of my own. So this is where we'll use blueprint interfaces. Alternatively, if you did use cast, the functions will appear. But again, cast nodes will create hard references to different actor classes. So we're not going to do that. For a blueprint interface, we need to create a new blueprint and then a blueprint interface. I like to start them with BPI just so I know what they all are. And then call it something reasonable. And this is where you define your function or event calls. And I will just call it register with CCA. And then I will make a new function. And we'll call it unregister with CCA. And on this one, just to demonstrate the differences, I'll give it an output. It won't be used. It's just to show you how it looks differently in the Singleton. For both of them, you want the input of whatever arguments you're going to be passing. So in this case, it will be a structure reference. And same with register. And then we save and compile that. Now on our Singleton, this is where you would implement your blueprint interface. And all that means is it will add custom functions and events on the left side that any actor will be able to access. So in class settings, under interfaces, implemented interfaces, we will look for BPI dummy smithy. And once we do that, you'll notice the interfaces section appears in the My Blueprint section. This one is gray and this one is yellow. And the difference is the unregister is a function because it has a return value. And the register is an event because it doesn't. It also means that it lands on the event graph. Normally I would just have them both as functions so they're not on the graph cluttering it up. But just to show you, that's why I did it this way. All we do within here is we call our events here. And pass along the structure reference. And the same with unregister. This doesn't matter, we're not going to use it. So all you have to do is in your structure, for your register event, which gets called after we find a valid reference to our Singleton, is we get our Singleton ref, and we call register with CCA. And you'll notice comes up with this, with a funny little envelope in the corner. That means it is a blueprint interface function call. And then we pass in self. To undo all this, we want end play on the server. Not the preview structure. And then we will get the unregister with CCA interface call. Just as a slight overview, just so everyone's up to date. Begin play on the structure will fire, not a preview structure, on the server. We'll get our Singleton reference, or we'll try to until we get a valid reference. It'll happen really quick. You probably won't even notice. And then we'll register our structure. The register takes a Singleton reference and it calls register with CCA. The end play, as in when the server is shut down or if the structure is destroyed or picked up, something like that, it will unregister this instance with our Singleton. the Singleton with register. We'll add it to a list of smithies that have been registered, and then we'll update an integer that's replicated. And on unregister, it will remove that instance, and again, update the count of total smithies. The only problem now is we have no way of accessing this without using our cast, but we can still just use our blueprint interface and just add another function to it. So we will do something like get number smithies, and we will return an integer. And then when we go back to our Singleton, a new function appears, and we'll just return our replicated variable. In our structure, this is still fine. You remember last time this wasn't even used because the client couldn't fire it, but it's still fine. The allowed to build will make some changes though. We can get rid of this. And this isn't useful. But what we can do, get our Singleton reference, call our interface function. And since this is a replicated actor, and the integer on the actor itself is also replicated, that means the client and the server can run it. So we can get rid of this. And then we will just check how many this is. So if it's greater than 3, it'll be denied. And then we'll test it out. So 2's fine, 3's fine. 4's denied, but this should probably be red right now. I don't think it should allow us to even try to place it, which means I screwed up somewhere. So our allowed to build function runs on the server and on the client, but this variable here, CCA reference, is only ever set on a get CCA function. And it's blocked right here by authority. So the client's never setting it. So when they go to place it, this is invalid, and this will return the default value of an integer, which is 0. So that's why the preview structure is never going red, because it's comparing 0, is it greater than 3? No. So it's never turning into an invalid placement. So we have to move that, and then change just a couple of things. So we need a reference to the Singleton, but we don't want to register it unless it's the server. So we can stop it there. And then, just in case, we will also prevent it from registering if it's a preview structure. Now, because of how Arc does things, after you place a structure, this technically fires once more, and the register event might actually be going through a little too quickly and causing issues. So if we stick a tiny little delay here, which I don't really love doing, but sometimes it's necessary, pretty small, it should fix the problem. So what'll happen, you go to place a structure, we'll get a reference to the Singleton. If it's on the server and it's not a preview structure, meaning it's already been placed, we'll register the actor. And then a tiny little delay, and then it registers with the Singleton. So we will test it out, and it should work this time. And there we go. We're not allowed more than 4. Because we did greater than 3, so if you want to shrink it down, you can. We can just go back in here, and we'll just change it to like 2. Greater than 2, meaning you're allowed 3, so if you want to only have 2, you can just do this. Also, consider the fact that if you change it like this after a live server's already been launched, it won't retroactively delete structures or anything like that, so we're already past the limit, and we'll still be past the limit, and we'll still be past the limit. So take that into consideration. But after that, first one goes down, second one goes down, and third one says too many already built. So again, a short little review. Ignore that. Structure is placed, or I should say begin play fires. This happens when the previous structure exists too, so Singleton is trying to be set here, and it will keep trying until it gets one. This will happen almost instantaneously, so it's nothing to worry about. If it's the server and not a previous structure, register the actor. So this would be when it's already placed or you successfully place the structure. It registers with the Singleton. End play on the server for not a previous structure. This would be destroyed, picked up, etc. We will unregister it. With the allowed to build, it simply returns the reason, and the reason is only changed if the number of registered smithies is greater than or equal to 2. And then it says -42. And -42 is the reason too many already built. The CCA only has a couple of events, which honestly, you could turn into functions and get them off the graph. That's fine too. You could also change this one in your blueprint interface so that it has a return value, and it will appear with the unregister event on the left side rather than on the graph, like this. Register adds a reference to the structure into the array and updates the count. Unregister removes a reference and updates the count. That's basically all it does. And if we look at our reference viewer, we see that there is no references to our Singleton because it doesn't directly talk to it. It talks to the interfaces. Nothing here. There's our interface, but no structure, or no Singleton. So if you wanted to add more functions, you could just open up your blueprint interface and add something else. I have no idea what that might be, but you know, whatever you want. We have register and unregister, and then just get a count, just to keep it simple. If you wanted to do it with like number per player kind of thing, you would have to use something a little bit different. You would need to track who owns it, like who placed it, based off of a unique characteristic like their player ID or their EOS ID, which is Epic ID. Something unique to them at least. Same thing with a tribe. If you wanted to do it based off of a tribe, you can get their targeting team, which would be the tribe ID, and keep track of that and how many they've placed. But it would need to be a little bit different. Like you would need to have a map or something like that of an ID pointing to how many have already been placed. And when you register it, you'd have to only update that index for that map with a new count. It'd be quite a bit different. You'd need some functions to look up how many each tribe is placed, rather than the total number of smithies placed, that kind of thing. Same principles though, just a little bit more complicated.